Located close to the French border, John Deere Zweibrucken has been producing agricultural machinery for more than 150 years. Today it is the worldwide production centre for self-propelled forage harvesters and a major European combine harvester producer. More than 1,000 highly skilled people work here, supported by a strong apprentice workshop which is constantly developing talent for the future. With a seasonal production cycle, flexible labour relations are essential for success. So too are quality processes. The sheet metal department is where every harvester begins its life. Working 3 shifts, the punch presses are the industrial equivalent of a Swiss Army knife, swapping up to 21 tools during a single operation to make more than 500 different parts. The presses are complemented by a team of 6 2D laser cutter machines. They are programmed to cut more than 4,000 different part types and will produce around 1.7 million parts a year. Working on sheets up to 25 millimeters, they cut the steel with such smooth edges, no further machining is required. Many of these parts are used to build the cutter heads and drums that are the heart of every harvester. A forager cutter head weighs around half a ton and spins at up to 1,200 RPM. With fractions of a millimeter between the knives and the shear bar, they have to be balanced with absolute precision to ensure reliable high-speed cutting. Small counterweights are attached to ensure perfect stability and vibration-free operation. The same precision engineering is applied to a combine threshing drum and concave. Robotic welding machines produce consistent joints which are incredibly strong. The finished assembly is then tested for balance and run at full operating speed before it makes its way to the assembly line. Even though advanced tools are used extensively, some processes like the creation of an unloading auger tube still require traditional skills. Shaped from a flat sheet of steel, it takes a highly experienced craftsman to produce. Before entering the production line, material verification processes ensure components meet the strict production standards. Individual parts are thoroughly inspected for hardness, coating thickness, and 3 coordinate measuring machines check the accuracy of dimensions. Quality is assured with the development of the John Deere Assembly Assistance Tool, or JDAAT. JDAAT is part of a zero-fault strategy. It tells each assembly worker what part is needed, in what sequence, and the exact torque for tightening bolts. There are around 100 JDAAT stations throughout the entire assembly process. Each team has to sign its name to the machine before it passes on to the next station. This not only gives people a sense of pride in their work, it's a constant reminder that a customer will be judging the quality of their workmanship during the upcoming harvest. The grain tank and unloading auger, for instance, are assembled by a team of 18 people. Bringing together over 360 different parts, they ensure every seam and part will withstand the weight of up to 14,100 litres of grain. The tank is welded for added strength, and the smooth sides ensure grain does not get caught in crevices for complete unloading. With a fully loaded combine weighing up to 37 tons, the thick steel panels are essential to withstand the stresses and strains of passing over rough ground at high speed. Once completed, each body undergoes a thorough 45-minute inspection before the corrosion protection and painting process can begin. Each body passes through a series of cleaning and degreasing baths to remove the slightest trace of oil and contaminants. Only then is it ready for electro-deposition coating, or E-coat for short. An electric current positively charges the combine's body to electrostatically attract the particles suspended in the bath. The first stage is zinc phosphate corrosion proofing, followed by several different paint coatings. Fully immersing the body guarantees every corner and compartment is protected. The electric current ensures an even coat on bends and cavities that would not be possible with conventional spraying. This whole process takes 6 hours, including a final bake to 130 degrees centigrade to ensure everything is totally dry. The treated housing then undergoes a high-quality final top coat, which uses 80 kilograms of paint. Apart from making the new combine shine, it has a practical use, protecting the other coatings from the harmful effects of UV light from the sun during the hot summer days of the harvest. The painted bodies are then transferred to the final assembly halls on the other side of the site. These new purpose-built facilities include up to 28 separate stations. Components arrive just in time from the worldwide factory network. Engines, transmissions, cabs, and electronics are all coordinated to match each model and individual customer order. The giant 970 horsepower 12-cylinder engines for our 9000 series harvesters are supplied by a John Deere partner, Liebherr. Engines, cabs, belts, electrics are all added in the final assembly process. Each machine has its own build tag with the individual specification for a specific customer. More than 16,000 different combinations are available depending on the customer's needs and the regulatory requirements of the destination country. Once all the connections have been made, machines are charged with fluids. The final components to be added are the spout and tyres. The total build time is around 46 minutes per combine and 150 minutes for a forage harvester. Completed machines make their own way off the assembly line and into the I-Park. This track is specially designed to test dynamic performance. Each machine is wirelessly connected to the audit center and undergoes a series of tests for the next 45 minutes at full operational temperature. Machines return to the audit center for a final 2-hour inspection, including a blacklight UV leakage test on all hydraulic lines and connections. The journey from sheet metal to finished machine may have only taken a few hours, but the build quality of a Zweibrucken harvester is designed for a long life and years of high-capacity harvesting.